Good morning, everyone. I'm Nikita, and I want to talk with you a little bit about explainability. Okay, but before we continue, I want to ask you a simple question. Which number is bigger, 9.9 or 9.11? Who think 9.9? It's math. I think all think 9.9 because mathematically, really 9.9 is bigger. But when we ask ChatGPT, it tells us 9.11 is bigger. Claude also tells us 9.11. Google Gemini, I think it's like money, 9.11 more. Okay, Microsoft Copilot 9.11. It is IBM Granite, 9.11 is bigger, and Falcon also. And even local Llama run locally on my laptop tell us, so answer is 9.11. So, why does LLMs tell us wrong answer for this such simple question? And I will tell you a little bit later about it, because right now we have more important question. Can we trust AI? Can we trust it if it's lying to us? So, where is black box problem? As you see from this picture, where is I forgot this word, sorry. Inverse relationship between interpretability and accuracy. So, as you see, neural networks and random forest, it's models with good accuracy, but it have a lack of interpretability. So, it's work like black boxes. So, it's not so easy to understand why it came to answer. And in another side, this is linear regression, for example, and classification rules. These models are very easy to explain and be really easy to understand why it came to answer, but sometimes it have not so good accuracy. In simple terms, explainable AI is AI which can give for us explain decisions in a human readable manner or in visualizations. And it makes clear why it came to answer. So let's look at some examples. Okay, what we see here, it's brown bear. But if you load this image of brown bear to AI, it can tell us what it see. It see rugby ball or baboon, monkey, some trilobite. Do you know what is it? Brown bear, it's right bear, answer, ice bear, lion, chow. And if we use explainable AI, for example, deep feature factorization, it will highlight us areas which it sees as rugby ball, it's grass. So it's because a lot of images is rugby ball on a grass in the internet. And we see what trilobite is this thing from right. And brown bear, it's nose and glasses. Oh, okay, but our bear want to be a lion, it's okay. For example, if some doctor load image of patient X-ray into AI and AI tell him, okay, I think this patient have some illness, but without explainability, doctor should look inside this picture again and find why AI think there is illness. But with explainable AI also can highlight areas, and doctor just look these areas, look at original picture and understand if AI lie or if AI right. And one more example. For example, you want to take a loan for a new car or new home, and some AI from bank tell you, you rejected, loan rejected, you're not approved. Why? You ask people from bank, and they answer you. We have so good AI, it's so powerful, and you rejected. Why I'm rejected? Just trust AI. It's not normal, of course, and with counterfactual examples, they can tell you something like, you can increase income by 5,000 per year and have one more credit history year, or increase income by 10,000, or you can, for example, have credit rating more than 700, and it will be good counterfactual explaining. So, I think you already understand what explainable AI matters, and I want to tell you just about AI already make critical decisions. So it's already can give decisions in finance, healthcare, law, in supply chains. So we need explainable AI to explain some of these decisions and so on. You can ask me, okay, we need to create explainable AI from scratch or not? Yeah, of course not. As you can see from this slide, there is some toolkits and platforms for explanations. For example, Microsoft have responsible AI dashboard on their Azure service. It's like dashboard where you can use it for explanations. AWS has SageMaker, Clarify. IBM have a very good open source solution, AI Explainability 360, and Google have explainable AI and what if tool on their Vertex platform. And also Meta have Hackathon for PyTorch, and it's also open source. So if you use already Microsoft or AWS or Google, you can continue to use it and use explanations from there. But if you look for open source solution, and if you use PyTorch, you can go with Meta or with IBM. It can help you with anything, PyTorch, TensorFlow, and so on. If you want to implement explainable AI, for example, you have company which want to implement this, so from which side you need to start? First, you need to define why do you need explainable AI, and for who do you need explainable AI. For example, it can be you need to make explanations for your customers, or for debugging code for your engineers, or maybe it's just for meet the government rules. You need to choose right models and tools because some models, for example, some easy to explain models like decision trees for where maybe don't need too much explainability, but hard to explain models, you can use tools, for example, Lime or Sharp for neural networks models. You need also identify key features for your model. It can be, for example, if you want to understand which goods customer want to buy next, key features might be time of the day and which his buying history before, and which goods buy clients from this type of clients. And if you want to integrate explainable AI, better to not integrate it in the end stage of your AI integration, because it will be harder and cost more money. Of course, you need to test with real users and ask them, does these explanations understandable? Maybe there is some mistake. Is it normal? Do you understand it? And integrate into AI lifecycle. It means your AI grow up day by day. So you add more data. It can be another model on another side of your model. So you need to add explainability, and not just add explainability, but make it better in every stage of your AI. Okay, about selecting right explainable AI techniques. As I told on previous slide, you need to know your model type, because on some models you need different explanations. Also, understand who is your audience, because if you make explanations for doctors, you need to use doctor's terminology, and if you use explanations, for example, for a patient, you need to use simple terminology, and you need to know which approach you want to use. Model-specific approaches where they can be used on only several types of models, not for all models, only for particular types of models. And model-agnostic approaches can be used on almost any types of models. And you need to balance how many things you want to explain to your people, because sometimes you need to explain less because it's more easy to understand. And you need to consider, do you want global or local explanations? Mostly you want and this, but for different audience you need different explanations. Little bit about designing explanations for your users. So you need to focus on user perspective. Think about for who you make explanations. And good rule, if you really understand this explanation, it's a good explanation. You need to use clear, simple language. Think about for which role of user you do explanation. If you can also add not only words, but maybe charts, pictures to these explanations, and show only what matters most. But if user need, you can add maybe button, tell me more about these explanations. Of course, test these explanations with users, ask them, is it good explanation, do you understand all, and improve the explanation based on their feedback. Let's come back into our issue 9.9.11. Some scientists also ask this question and watch inside model. And what they found, model don't think it's like a numerical or math problem. It's watches sequence problem. So it's look for dates because 11 September is more than 9 September or 8 September, and also it's find references to Bible and another religious book because chapter 9 and verse 9 less than chapter 9 verse 11. So you need to prepare now for regulatory because it's already becoming mandatory. For example, Europe have AI Act from April 2024, and if companies don't follow rules, they can be fined up to 35 million euros. Okay, imagine some technology. For example, you load your model into this technology, and it tells you why your AI came with answer, and it tells you because it's work like MRI. It's look deeply inside your model, and it's know almost everything about your model. In April, 1 month ago, Dario Amadei, its CEO of Anthropic, write an article, Urgency of Interpretability, where it describes future technology MRI for AI, and it's interesting, and maybe it can save us from future superintelligence which can come to us in a couple of years. And as told Arthur C. Clarke, ancient sufficiently advanced technology is indistinguishable from magic. So let's demystify artificial intelligence using explainable AI. By the way, my name is Nikita, but you can call me Nick. Here is my LinkedIn, and that's it.